Given question, draw shear force diagram and bending moment diagram for the cantilever carrying uniformly varying load.
In this question, cantilever carrying uniformly varying load where load is 0 at the fixed end B and load is equal to 6 kN per meter at the free end A. Total length of cantilever given 4 meter. And we have to draw the shear force diagram as well as bending moment diagram. First step is to draw the free body diagram to find out the reaction forces. So how to calculate the total load for this uniformly varying load? So this total load is equal to area of triangle ABC. So we will calculate the area of triangle ABC is equal to half multiplied by base multiplied by height. So base is AB which is equal to 4 and height is AC which is equal to 6 kN per meter. So we will calculate this which is equal to 12 kN. So this is the load for which it is acting. Now we have to find out the point of application of this load, that means center of gravity point. So we know that it is at a distance of 1 by 3 multiplied by total length from the maximum load, and it is at a distance 2 by 3 multiplied by the total length of cantilever from the minimum, that means 0 load. So from this point B, it is at 2 by 3 multiplied by 4 distance. So we will mark one point at that distance, and from this end A, because end A is with maximum load, it is at a distance 1 by 3 multiplied by 4. So this is the point of application of the load, and this magnitude of that load is equal to 12 kN. So we will mention here. Now if we observe, this end B is the fixed end and this load is acting at this point. So it will try to bend this cantilever about this point B in this direction. So to prevent this bending at the fixed end B, we have to apply the bending moment in the opposite direction. So this is the clockwise direction. So bending moment at this point B, we have to apply in anti-clockwise direction. And how to calculate this moment about B? So bending moment about point B is equal to, so with the help of compass, if we observe this load multiplied by this distance. So this distance is 2 by 3 multiplied by 4. So I will calculate here 12 multiplied by 2 by 3 multiplied by 4. Here is 32. So this bending moment is 32 kN meter and it is in anti-clockwise direction. So we have to mention this. So this is the data from free body diagram. So bending moment at point B is equal to 32 kN meter, and we have to mention the direction also, it is in anti-clockwise direction. Now if we observe here, this load 12 kN acting in vertically downward direction and end B is the fixed end. So at this end B, we have to apply the opposite direction force. So here is reaction at point B, that is known as RB. So this RB, if we observe, it is equal in magnitude but opposite in direction. So we have to mention here magnitude of RB is 12 kN and its a direction is upward. So we will mention here 12 kN and we have to mention its a direction also. Next step is to find out the formula to calculate shear force and bending moment at any distance x. So we will take this distance x from the minimum load, that is where the load is 0, that is from this point B. So we will mark this distance x from the point B. consider this point D. Now how to find out the load acting at the point D, because we know that from this B to C this is uniformly varying load. So I will mention here, or I will show here, this load at the point D, and this point of intersection is the point E. Now to find out the load at this point D, we have to find out the value DE. Now if we observe the diagram, then there are two similar triangles. First triangle is ABC. So I will write here from triangle ABC and the triangle DBE. We have to find out the value DE. So we will take the ratio for base to the height for these two triangles. So for the triangle ABC, base is AB divided by AC is equal to, now from the second triangle base is DB divided by DE. Therefore, now we will put the value. So AB is equal to 4, AC is 6 kilonewton per meter, then DB is X, which is equal to X divided by DE. Now we have to find out the value DE. Therefore, DE is equal to 6x by 4. We will simplify this, that is 3x by 2. Now we will mention here this value. At this point C, it is 6 kilonewton per meter. In the same way, at the point E, the value is 3x by 2. So I will mention here at the point E, this value is 3x by 2 and unit is kilonewton per meter. Now this value is mentioned in the diagram. Now we have to find out the magnitude of this load acting in between this span B to D, that is acting in between this distance x. So how to find out the magnitude of load? So we know that load is equal to, because this is uniformly varying load from point B to E. So we have formula, that is equal to area of triangle BDE. So we will calculate the area. So half multiplied by base. So base is x multiplied by height. So this height, that is D to E, and it is 3x by 2. So when we simplify this, we will get 3x square by 4. So this is the load acting in between this B to D. Now we have to find out point of application of this load, or we can say that center of gravity point. Now if we observe at this point B, load is 0, that is minimum, and at this point D, load is maximum and it is 3x by 2. So we know that center of gravity point, or point of application of the load, is at a distance 1 by 3 multiplied by this total distance from the maximum load. So maximum load is at point D. So from this point D, we will plot the point at a distance 1 by 3 multiplied by x, and it is at a distance 2 by 3 multiplied by x from the minimum load. So from this point B, we will consider the point 2 by 3 multiplied by x, and this is the point of application of this load. And what is the magnitude of this load? So it is 3x square by 4. So we will plot it. From the free body diagram, we have to plot this reaction force in upward direction 12 kilonewton, then this bending moment at this point B, as well as this load 12 kilonewton in downward direction. Now we will find out the shear force at a distance x, that is the shear force at this point D. So we will consider the summation of forces which are on the left hand side of this cantilever. So which forces are on left hand side of this point B? So it is 3x square by 4, which is in downward direction, and here 12 kilonewton, which is in upward direction. Now we have to consider the sign convention, and we have to mention this in the answer sheet. So here are the sign convention. So this point of intersection for this vertical and horizontal line we will consider as a point P. So when the forces which are on the left hand side, and when forces are in downward direction, then we have to consider the negative sign, and when upward direction we have to consider the positive sign. So if we observe from this point D on left hand side, this 3x square by 4 is downward direction. So we will take here minus 3x square by 4. And this 12 kilonewton is in upward direction. So we have to take this positive sign. So plus 12. So this is the formula to calculate shear force at any distance x. So this is at a distance x. Now we will move to the next point. Now we will find out shear force at this point B. Now at this point B, we know that this distance x is equal to 0. So when x is equal to 0, then how to calculate this? So this whole term will become 0. So SF at B is equal to plus 12 kilonewton. Now next we will move SF at A, shear force at A. So x is equal to, that is distance from this point B is equal to 4 meters. So we have to plot here 4. So I will write here x is equal to 4. So when x is equal to 4, I will calculate minus 3 multiplied by 4 multiplied by 4 divided by 4 plus 12. So this 4 is getting cancelled. So here minus 12 plus 12, and it is equal to 0. Now we will consider any middle point in between AB. So if I consider the point P as a middle point, then the distance from the point B is equal to 2. So we will find out shear force at x is equal to 2. So this is for the more accuracy when drawing the shear force diagram. So we will put the value x is equal to 2. So I will put minus 3 multiplied by 2 multiplied by 2 divided by 4 plus 12. So it is 4 is getting cancelled. So 12 minus 3. So it is equal to 9 kilonewton. Plus 9 kilonewton. So here is plus 12 kilonewton. Now if we observe, we have to note down these three values, that is shear force at B plus 12 kilonewton, shear force at A it is 0, and shear force at P, that is at the middle point, it is plus 9 kilonewton. Now we will find out the formula to calculate bending moment at any distance x, that means bending moment at this point D. So we have to first understand the sign convention. For this diagram, we will take the summation of moment of the forces on left hand side from this point D. Now if we observe, here is the bending moment which is in anti-clockwise direction, and it is on the left hand side from this point D. So whenever this anti-clockwise direction bending moment and it is on left hand side from this point, then we have to use the negative sign. So we have to mention the sign convention in the answer book, and then we will write here. So it's a value, bending moment at B is equal to 32 kilonewton meter. So we have to use here with negative sign. So it is minus 32. Now next is the reaction at this point B. So it is in upward direction. So if I move the compass about the point B, then it is in clockwise direction, and it is on the left hand side. So for clockwise direction and on left hand side, we have to use positive sign. So what is this moment about this D? That is this force, that is we will use the plus sign, plus this 12 kilonewton multiplied by distance in between this force and this point D. So it is x. So I will write here plus 12x. Now next we will move to the 3x square by 4. So if I move the compass in the direction of this force, then it is in the anti-clockwise direction. So we have to use the negative sign. So we will use minus. Magnitude is 3x square by 4 multiplied by the distance in between force and this D. So it is x by 3. X by 3. Now we will simplify this. So I will take here minus 32 plus 12x minus 3 this 3 is getting cancelled. So x cube divided by 4. So this is the simplified form from this equation where bending moment at a distance x, we will calculate bending moment at point B. So we know that at point B x is equal to 0. So when we put x is equal to 0, then we will get bending moment minus 32 kilonewton meter. Then bending moment at point A where x is equal to 4. So when we put x is equal to 4 in this equation, we will get bending moment at point A is equal to 0. And bending moment at point P, which is the middle point. So at a distance x is equal to 2, when we put the value x is equal to 2, then we will get it is minus 10 kilonewton meter at x is equal to 2. Now we will plot the shear force diagram as well as bending moment diagram. Now when we observe the formula to calculate shear force, then it is in terms of x square, that is second order equation. So it will follow the parabolic curve. And for bending moment it is in terms of x cube. So it will follow the cubic curve. Now we will show these curves. So first we will plot the shear force at point A. So here is the point A and shear force is 0. So we will plot here the point on the baseline. I will mention here the value 0. Then at point P it is plus 9 kilonewton. So we will plot here one point and value is plus 9 kilonewton. And this is at the middle point. And at point B it is plus 12. So whenever the value is having positive sign, then we have to show it in the upward direction. So I will mention here it is plus 12 kilonewton. Now we will connect all these points. So we have to connect these points with parabolic curve. We will complete this diagram and we will show this is the parabolic curve. Now we will move to the bending moment diagram. So for bending moment values are negative. So at point A value is 0. So we have to mention here 0 on the baseline. Then next at the middle point it is minus 10. So for minus 10 we have to mention below this horizontal line. So I will mention here the value is minus 10 kilonewton meter, and at point B it is minus 32. So minus 32, that is it is far more than minus 10. So I have to mention at the bottom it is minus 32. So no need to give here the sign because we have already plotted these points below this horizontal line. So we will only plot here 10 and 32. Now we will connect these points. And when we connect these points, then we will get the cubic curve and we have to mention this. And we will also highlight the area. So for this SF or shear force diagram, we have to give here the heading SFD. And for this BM diagram, we have to give the heading BMD.